the Microsoft Machine Learning Studio. It does have some things that I think you can get into even if you're not a developer. The framework for all of this is, all right, we've got a super complex problem or a super complex data set that we want to analyze and use to solve future problems. The beauty of this is if you have your data in Azure already, it is quite simple to connect it to your Azure data environment. You can do custom queries to pull only exactly what you need out of that data. It also has lots of automated features to help you pick the right model, analyze things, and it also has access to thousands of machine learning models by default. There's some neural network models. So to think about this, it's like, what are you trying to predict? And then based on that, what data sets do you have available that can be predictive of that? As anybody who has experience with machine learning will tell you, is preparing your data, aka doing pre-processing, is probably the biggest part of this entire process. There are some built-in tools to help with that, but I'll be honest in that a lot of the pre-processing is still going to require you to think about it manually. And that is sort of the biggest component of it. So you got to go backwards in time. What are you trying to predict? What data do you have that would be valuable for it? And then the follow-up step is, how do you clean up that data to be useful in a machine learning environment? And then the next steps are actually the easy parts. Connecting the data, no problem. I'll show you how to do that. Pick a model, no problem. Training can use up some compute resources, but other than that, it's not the most complex thing. And then deploying it is really just an extra step on top of all of this at the end. So the way that you can think about the Machine Learning Studio, and again, this is all just available as a part of Azure. You can deploy a workspace like I have here. We've got multiple workspaces. This is just like my demo workspace environment. We do have our production ones that we use for internal tasks. But this is really the interface, and it gives you everything that you need for actually setting up a machine learning environment. So the two examples I'll give on the use cases for this, one is like the training example that we went through as a part of like the Learn Machine Learning Studio course. And then the second is what we're using it for in the real world, because I think it kind of frames what's possible here. So one of the examples that they use in the training on this is you've got all this data set up and stored about your temperature data, your day of the week, your traffic, your sales. And in this case, let's say you own a bicycle rental studio. Nice and simplistic example. What the example allows you to do is feed all that data in, train a model on how to predict how many bike sales you can expect on any given day based on all those variables, and then spit out an output. So that's like classic sort of regression analysis where you want to have a number as your output. You have a bunch of data points for the years of your business, and you can put those in, train up a model, and get a result as your outcome on what you can roughly predict. The example that we're using internally is a classification model, which is we look at invoice data and then predict what dimensions or GL codes need to be associated with that. To get started with this, step one is you need some data. And data can be as simple as a bike rental spreadsheet that you have. So if you got the data stored locally, it can be as simple as that. In our internal case at Fidesic, we've connected it with a special database that we've set up that has some invoice data on it specifically for training. But step one is to actually connect some data. So once you've got your data connected, you've got two different options on how you can approach from there. So step one, if your data is already in great shape, you can use the automated machine learning tools that are built into Azure. So if we go into one of these data sets that we printed out here, basically what automated machine learning does is it will test your data against several hundred different models that are already built into the site and give you an output of what it thinks that best model is. As you can see, our best model is this extremely complicated long name model that it went through. And you can check out the models that actually are the output of this. So the winning one for the bike model is going to be, we have our actual model outputs here. So extreme scalar wrapper, extreme random trees, I'm not gonna pretend I know exactly what's contained within this model, but that is the type of model that you would then use for training. If you need to do more pre-processing on your data to clean it up, to make it more friendly, then you can use the designer. And this designer is really where the bulk of what's going to be set up actually takes place anyways. So we've got our data, we've got our automated, if we want to come up with a model, we've got our designer to use the model. And then to do any of this, we're going to need some compute units. So this is what I've alluded to, that this is also just built in here. You can build a cluster of compute clusters or instances here. These are really easy to set up. You can just basically pay for how much resource you think you actually need. In this simple example, we just needed a CPU processing unit. For our more complex GL code classification example that I've been working on, that is a full array of GPUs doing the actual processing. And then this, once you've got this set up, this is what actually does the analysis. So again, you need some compute units to actually run the data. This is how you set it up. It's quite easy to do. Assuming you need to set something up, the designer is where to do it. And think of designer as the actual like workflow of your machine learning project. So it's a nice visual editor, which makes it easy to follow along with what's going on. And every one of these nodes is fully configurable. So in this example, we've got some automobile price data that we're trying to make predictions on. You can then pick what columns you want from your data set. Again, just using SQL, nice and easy. You can clean up missing data, normalize the data. There's a whole breadth of knowledge out there about how to pre-process data. I suggest it's worth looking into. It's far beyond the scope of what we're doing here, but you can add all those pre-processing steps here. So this is what I was talking about, where if your data is perfect, you can send it to automated and run it against everything. If you need to clean it up first, you can do it using this designer. And then this is the actual model that you're going to run against this data. So there's a ton of different built-in models into this situation. So we've got all our models that we could potentially have. These are customizable too, so you can make modifications to it, change how it actually analyzes it. But at the end of the day, this is your machine learning flow. So you've got your input data, you clean your input data, you split it off, you train it against a model, and then you get an evaluation or an output of that. And what you'll do is you'll submit this flow to one of your compute units, and that is what is going to give you an output, which one will allow you to send real world data in it after the fact, and two will tell you how good your model is actually doing. So you get an output. It's really a process of going through this and tweaking it and making sure that you're improving more and more and more. Once you've done that, you've run your data through, you've got an output of you've got a good model that is fairly predictive or predictive enough for your purposes. What you can actually do then is you can connect that to your real world data. So in the same sort of interface where you have your designer, you can submit it here. And then you've got the difference of this is not only do you have your models that you've trained on, you also have the ability to have a web service input and a web service output on that. So this is when we start predicting with real world data. We're able to send some new data in, run it through the same transformations, run it through our evaluation and our thing that we trained up on, and then we've got a web service output. So I know this seems like a whole lot. The hardest part of this is just like sort of understanding how the flow works, and then it's just a matter of playing around with the data. So again, the steps would really be pick what you're trying to solve, build the data set for it. You got your data set, allocate some compute units so you can figure out what's going on, design a model and train your data against it, and then you can go back and connect it through to that real world data.